So now you have an idea of what E is. It's a number. It's the number 2.718 with a lot more following that. E is kind of like the pi of algebra. Pi is that 3.14 that we use in geometry, calculating things that have to do with circles and different angles. And so E is a number used commonly in algebra, especially dealing with exponential growth. And the way that we'll use it in expressions or equations, it doesn't really act any different than using x. We can combine it with other terms that involve e. We can combine the exponents. And then since it's a constant, if we have terms that just have e's, we can calculate that and get a decimal answer of what an expression might be equal to. So just a few examples here. If we want to evaluate or simplify e to the fourth times e to the seventh, that's really no different than looking at x to the fourth times x to the seventh. We have the same base, so we can just add those exponents. So this would be e to the 4 plus 7, so e to the 11th. And the next example, we have 60 e to the 8th over 12 e to the 3rd. Hopefully problems like this are familiar from a couple chapters ago. We deal with the two parts separately, so 60 over 12, that reduces to 5. And then e to the 8 over e to the 3rd. Since we're dividing, we would subtract those, or think about how 3 of them cancel out with 3 of them on top, and so we would have e to the 5th. And in the last example here, we have some expression raised to a power. So that third power goes to that negative 10. So negative 10 to the third, that's going to be negative 10 times negative 10 times negative 10. That's going to come out to a negative since we have an odd number of negatives. 10 times 10 times 10 is 1,000. And then we have a power to a power with the base of e. So we're going to have e to the, when we have powers to a power, we multiply. So negative 5x times 3 is going to give us negative 15x as the power of e. In these next examples, I want you to get out your calculator, and we're going to actually give the decimal of what one of these expressions is equal to. So on your calculator, you'll need to look for an e to the x button. Maybe all you see is an e, or maybe on some of them it's going to be above this ln button, and so you might have to do the second or shift to get your e to the x. You're not looking for a capital E. Some calculators might have a capital E or like a EE button. That's something else. We don't want that. We want this little lowercase cursive looking E. Okay? So you're looking for that on your calculator, and it should be pretty simple to just plug in. Some of them, once you push that button, it'll take you up into the exponent, so you would have to put in e to the x, and then you press 5 because you want e to the 5th, and that comes out to 148.4. And just remember what we're doing. This is really 2.718 to the 5th, so it's almost 3 times 3 times 3 times 3 times 3, right? Almost 3 to the 5th. The next example, just a little bit more to plug in. But you should be able to just plug that in all the way across if you've got one of the scientific calculators that lets you do that. So 10.4 times e to the negative second comes out to 1.407. Pretty simple. The last thing that I want us to look at with e is just the graph of e to the x. This is kind of the most normal or common exponential growth function, I guess. So if we do e to the x, I've already filled out the table of values. Of course, at 0, e to the 0 would still be 1, and e to the first would be that 2.718. That's the value of e. And then you've got the rest of the tables on, or the values in that table. So if we plot those, we're at -2, practically 0, -1.37, 0, 1, 1, e, 2.718, and then 2, 7.39. And so it's going to go and increase up through those very quickly. It goes out to the left, getting closer and closer to our x-axis, but again, never going negative. So there's y equals e to the x.